Good evening guys and welcome to today's video. Right guys, today's video will be integration part 2. So we are going to be looking at how and why we use integration in mathematics. Okay. So we'll be taking a look at that for today's lesson. Right guys, so integration, okay, so it's for AS and A2 maths, obviously further maths GCSE, and then also university level maths. Okay, I'm planning to try and make the video actually for an 8-minute video. Okay, so that's my obviously aim for today's lesson. Okay, so it would be a short video on integration, with 2 examples. Right guys, so integration, so from our first lesson on integration, so we said the integral of x to the n dx, so it's a function f of x dx is equal to x to the n plus 1 over n plus 1 plus c. Okay, so that plus c here is what I call my integration constant. Okay, so if we don't have a limit here, so if we don't have any numbers on either side of the integral, then it's what I call an indefinite integral. So this is what I call an indefinite integral. Okay, and then I have the plus c. If I have a definite integral, which is what I'm going to be looking at in today's lesson, okay, it will just be there will be no need to put a plus c there, okay, right guys, so example, okay, so purpose of integration, okay, so it's used to solve differential equations. Okay, it's used to find areas under a curve, areas between a curve and a line, areas between curves, circles and lines. Okay, so they're the main 4 purposes of integration. Right guys, okay, so example 1, so find the integral here between x equals 1 and x equals 4 of 3x minus 5 dx. Okay, so it will say find the area between the line x equals 1 and x equals 4. Right guys, so first of all, actually, I've actually sketched the graph actually. So 3x minus 5, so it's a sketch, guys. So it's a gradient of 3, and then the y-intercept crosses at minus 5. Okay, y equals mx plus c. Okay, so I hope that's that's clear, guys. If you're not sure, obviously, check out my video that I've made on straight line graphs. Obviously, so this one we are actually integrating a linear function. Okay, right, guys. So integrating this, so we are gonna add 1 to the power. Okay, so obviously we've got power 1 here. Remember, so it's 3x power 1. Add 1 to the power and then divide by the new power. Okay, and then we've got minus 5. It's gonna be minus 5x over 1. Okay, so my integration here between 4 and 1, it will be 3 over 2x squared minus 5x between, okay, so I'll put it in square brackets between 4 and 1. Okay, I'm not sure why I've put an 8 there. It should be a 4 there, not an 8. Should be a 4. Okay, we don't need the plus c here because it's just a rule here about if we have a integral with limits, we don't need a plus c, because if we put a plus c here in, then we would have to put it in for this limit and then the other limits. Okay, so they would actually end up actually cancelling out actually, which will be made clear in a second. Okay, right guys, what I now do here is sub in my values. Okay, so I sub in the value for x equals 4 and then I subtract that from my second one. So you always, so you sub in the top one first, subtract subbing in the bottom one. Okay, so working this out, guys, okay, we should get, so 3 over 2 times 4 squared minus 5 times 4. Okay, so I'm just subbing in x equals 4 into this integral. Subtract 3 over 4 times 1 squared minus 5 times 1. Okay, 4 squared is going to be 16. 3 over 2 times 16, actually, it will be 48 over 2. I've made a mistake here, guys. Sorry, it should be 24 there. Sorry. Okay, so hopefully, it should be okay. So that's actually it would just actually change my answer there. Right, guys. Okay, minus 20. 5 times 4 is going to be 20. 1 squared is going to be 1. 3/4 times 1, it would be 3/4. Minus 5 times 1 is going to be minus 5. Okay, so 24 minus 20 is going to be 4. Okay, so we're going to do 4 subtract here. 3/4 minus 5. So 3/4 minus 5 actually I've worked out here. okay, to be minus 17 over 4. Okay, so it will be 4 plus 17 over 4. Okay, yeah, so 4 plus, yeah, actually it should be a positive there. So it will be, because that's going to be 16 over, so it will be 16 over 4 plus 17 over 4, which will be 33 over 4, which is obviously going to be my answer here. So 33 over 4 actually should be my answer. Not 1 over 4, sorry. So ignore this, guys. Yeah, ignore this part here. Okay, so it should be 4 minus 7 over 4, which becomes 4 plus 7 over 17 over 4. Okay, which will be 33 over 4. Okay, so I hope that was actually clear, guys. Yeah, so sorry if my handwriting's not very legible. Okay, right, guys. Okay, so that's, yeah. So the area, between 1 and 4 will be 33 over 8. So the area of this will be 33 over 4. Okay, so that was nice and easy. Right, example 2. The integral of x squared between 0 and 8. Okay, so again, 0 to 8. Okay, so it's this area here. Now this one could have actually been done a bit easier, because it was, yeah, I could have said, okay, well, use like an area of a triangle actually, which actually would have been true, but sometimes, yeah, the integrals will not be that simple. So it's usually on like quadratics, cubics, quintics, and like sine and cos graphs. Okay, so this one actually, yeah, obviously we can't actually draw like a triangle shape, because our area would be like an overestimate, because we would also have like this region here. Okay, right, guys. Okay, so 0 and 8. Okay, x squared. So we're going to add 1 to the power. Okay, so it says find the area between x equals 0 and x equals 8. Add 1 to the power, divide by the new power. The limits are 8 and 0, so it's always the top limit first. Subtract the bottom limit. 8 cubed over 3, which gives us 512 over 3. Subtract 0 cubed is going to be 0 over 3, which would be 0. Okay, so my answer would be, yeah, 512 over 3 square units here, or I can write it as a mixed number. Okay, I will leave it for you guys here to like write it as a mixed number, and this, yeah, can also be written as a mixed number actually, yeah, if you're interested. Okay. Right, guys, I hope that video, yeah, it was clear actually. So the summary of this video, guys, here was that integration is used, okay, to work out areas of lines and curves. Okay, so if we have a limit, okay, we don't need the plus c. Okay, the reason for that, yeah, is because if I put my plus c here actually, and then in my other bracket, so if you look here actually, if I put a plus c here, and then I put a plus c here, well, that's actually going to cancel c minus c. Okay, so that's why I don't need actually. So you can put it in actually, like, yeah, into the limit, but you'll realize actually, yeah, it will just actually, yeah, it will always cancel actually. So it will be c minus c, which will just be 0. X equals 1 and x equals 4. Okay. So I hope that was actually clear, guys. Yeah. So remember, yeah, integration, yeah, just means that we are adding 1 to the power and then dividing by the new power, and then we sub in our limit. So it's the top limit minus the bottom limit. Okay. Yeah, I hope that was like a clear video, guys. Yeah, and thank you for watching. But please do obviously, yeah, subscribe. Yeah, obviously if you are new, drop the video a like actually. Yeah, comment below actually. Yeah, like of anything, and I will see you guys hopefully tomorrow. Okay, thank you for watching, guys, and I'll speak to you soon. Bye now.